planet Venus, dancing between the Sun and Earth, showing us for a brief moment the true size of the solar system around us, but also revealing the nature of its mysterious atmosphere. This is the transit of Venus.
The transit of Venus is a rare event, occurring twice per century on average. And so rare that basically a person just have one or two opportunities in its life to observe it. And what it is simply the small disk of Venus passing in front the disk of the Sun. The history of observations of the transit of Venus is fascinating because it was first observed in the 17th century, and then soon the astronomers realized that it was a unique opportunity to try to determine, to solve one of the most important questions at the time, the scale of the whole solar system, just by measuring the distance between the Sun, Venus, and the Earth. This was so important at the time that they organized huge expeditions. It were years of preparation and travel to go transport instruments toward hostile countries far away in the Pacific, toward populations that were poorly known, install the instruments, hoping the weather was good for just minutes of time during the transit. It's quite incredible to think that in 1882, when this observatory was founded, was being built, Henri Perrotin, his first director and astronomer, went to Patagonia, organized an expedition to observe the transit of Venus in 1882, 6th of December. Here you have the official registers of the mission, where all the information are copied, and it starts by describing the arrival in Patagonia till the day of the transit on December 6th. And on that very day, the note starts, the sky is completely covered. In the morning, it rains. But at a certain moment, the transit has already started, and they can see Venus half on the disk of the Sun. And they start to measure the event. I realized in 2004, with the first transit I was able to see of Venus, that there was something in it that was possible to exploit, to study Venus itself. This thin aureole of light that was already seen in the 18th century, first in 1761, by Lomonosov, a Russian astronomer, it is visible only at the entrance and the egress of Venus, so just at the beginning and the end of the transit. 20 minutes at the beginning, 20 minutes at the end, about. So it's a very short time frame that we can exploit to probe the atmosphere of Venus in the layers where this light passes and produces this phenomenon, which is also called the aureole of Venus.
The aureoles of Venus. How can anyone observe something so faint in broad daylight without being completely blinded by the sun? Paolo's team and the workshop of the Côte d'Azur Observatory took up the challenge.
We exploited the idea of using a coronagraph. That is a device that is capable of hiding the light coming from the solar disk to better show what is close to the Sun. It was built essentially here at the Observatoire de la Côte d'Azur. You can see here how the device looks like. It was inserted at the focus of a simple commercial telescope. And the core of the device is this cone here, which is a solar occulter, it is called. It has exactly the same size of the Sun in the focus of the telescope. So it can completely hide the light of the Sun, and we can easily see, close to the Sun, the light of the aureole this way. So I was lucky to have here 9 of those instruments in Nice, assembling them. And then a few days later, it was quite impressive because they were traveling all around the globe. And I was receiving pictures of people in Australia, in Japan, in India, with those telescopes around the world. It was pretty amazing, just a few days after. And then the right moment came. And it was a fascinating experience, because when I first realized that everything was going well, and we started seeing on our computer screens the auroral forming while Venus was approaching the Sun, I knew at that right moment that we were being successful with the experiment. And soon afterward, I realized that, wow, we really did that. And it was once in a lifetime, it was gone, just gone. And it was a kind of strange impression. And I say, after with time passing by and looking back to those exciting moments, I really realized completely how great this opportunity was to see the transit and to be able to have an experiment built for that, even if it was done with simple instrument basically, but targeting real science.
For almost 4 years, Paolo has been analysing the data from those incredible 40 minutes. From thousands of images captured, he has managed to make them come alive and reveal new details about the atmosphere of Venus.
And for example, this image showing Venus against the solar corona also shows this very, very bright aureole, because there it is the polar region of Venus where the clouds ends at a lower altitude. So there is more transparent space for the light to pass through this atmospheric layer, meaning that you have more light, the aureole is brighter, and we can see it when Venus still has to begin the transit. So we were very lucky, because during the transit, the Venus Express satellite of the European Space Agency was observing Venus, basically at the same time. So when we were observing from the Earth, seeing the aureole all around the limb of Venus, and the Venus Express was performing a very specific measurement, very close, of course, with much detail. So at the same time, we have a reference point, that is the latitude observed by Venus Express, that allows us to control what we are doing, and the measurements from our ground-based experiments, in which we see all the latitudes together. For the first time, we are able then to extract the information on the physical conditions of the atmosphere for all the latitudes at the same time. These observations of the aureole are the demonstration of a reality that we forgot sometimes. Namely that even when we build space missions and huge telescopes and the probes that go to the planets very close to them to observe their surface in great detail of their atmosphere, but even then, the instruments that are on the ground, far away, maybe sometimes small instruments, still have information to bring, still can give a contribution. And so the two approaches are completely not in conflict, but complementary, because they see different things, different level of details, but both are important.
Science is more than mere calculations and numbers. It's about determination and curiosity, about putting all your energy looking in one direction without being sure of what you will find. In about 100 years, the next transit of Venus will without a doubt once again bring its share of discoveries and remind us of the amazing scale of the elements around us.